Everyone, in this video we are going to prove that a Cauchy sequence is a bounded sequence by using direct proof technique. So we should start from what we know. We know that we have a Cauchy sequence. So let's assume that one Cauchy sequence. Let's say that the sequence an be a Cauchy sequence. Then we can use the definition of Cauchy sequence. As all you know, the definition of Cauchy sequence is for all epsilon which is greater than 0, there exists big N such that for all nmm which is greater than big N, we have what? Absolute value of an minus am must be less than epsilon. This is the definition of Cauchy sequence. And do not forget that what we are going to prove. We are going to prove that this sequence is bounded. So how can you prove that one sequence is a bounded sequence? We need to find there exists m such that for all n values, absolute value of an for all terms must be less than this m. If you can find this m, you say that your sequence is bounded because all terms must be bounded below and above. This is absolute value. You know that this is the definition of that one, right? So you can use that one or that one. So let's start. How can we prove that? We are going to use the definition of Cauchy sequence. We know that it starts from for all epsilon. So it holds for every epsilon. Specifically, we can choose one epsilon. Let's say that epsilon is 1. And also, we can fix the value m. Fix one of m. We can consider only one m. Let's say that it is m0, but say that this is greater than n. Here we choose our epsilon, which is 1. That means there exists n, big N, such that for all n values, which is greater than big N, absolute value of an minus am0, am0 is already greater than big N, it is fixed number, will be less than epsilon, and we choose epsilon is 1, so we have that one. Do not forget that we are going to prove that absolute value of an must be less than m. Now can you consider absolute value of an? Here I can write that absolute value of an as negative am0 and positive am0 because here is 0, right? Now I can use triangular inequality. If you choose these two terms, you can write like this, right? And the second term is am0, absolute value of am0, thanks to the triangular inequality. Now here you know that absolute value of an minus am0 is less than 1, so we can say that here is less than 1. Then we have absolute value of am0, and we prove that the terms an, absolute value of an, is less than 1 plus am, absolute value of am0. Now you know that am0 is a real number, so absolute value of am0 is a real number. 1 plus absolute value of am0 is a real number. So if you say that 1 plus absolute value of am0 is m, you prove that absolute value of an will be less than m. But it is not enough because we prove that for only when n is greater than big N. What about your first term a1? What about your second term a2? What about your nth term an? The rest we know that it is less than 1 plus absolute value of am0. Now here is the trick. If you think that this is a set, how many elements we have? 1, 2, big N and big N plus 1. So we have finite numbers and all of them are just real numbers. Why it is so important? Because if you have finite set, you can find your maximum value and you can find your minimum value. If you denote that your maximum of this set is m, that means for all values of n, we have what? Absolute value of an will be less or equal than m, because m is the maximum value of this set. Therefore, we can call that the Cauchy sequence an is bounded. And it completes the proof. If you have a Cauchy sequence, it is a bounded sequence. If you like this video, you can press the like button and you can subscribe my channel. Thank you for watching it.